Girls, it is I. I'm going to finish these notes. So here we go. All right. The next thing we're going to talk about, we've talked about in your the last couple classes ago. Oops, wrong way. Increasing and decreasing. Okay, now we're going to talk on, and remember, we're always talking about F, increasing and decreasing. Usually, I don't like to anyway, talk about F prime, but we can. But anyway, I'll get into that. So now we're going to talk about concavity. Okay, now basically let's look at what concave up looks like. Okay, this is concave up right here. Concave up. Slow pen. All right. Okay, now it's the same concept as a quadratic when we talked about that in Algebra 2. You said it opened up or it opened down. Okay, so concave up, of course, is opening up. Concave down is opening down. Okay, we're going to call this CD, concave down, CU, concave up. All right, now it doesn't have to be like unlike a parabola, it doesn't have to be totally opening up. It can be kind of this sideways opening down or up regardless. And so don't expect perfectly formed parabolas for concavity. You can have, slightly to the side. So anyway, let's figure out calculus-wise how we do this. All right, now, the second derivative, we talked about that the other day. This says it's positive, okay? That means F is concave up, okay? So the second derivative is positive, F is concave up. Now notice I'm not talking about this, so I'll get back to that in a minute. All right, concave down here is when F double prime, the second derivative, is negative. Okay, now let's talk about these slopes. Okay, so this is F. Okay, you can tell by looking at it, it's concave up, which means, analytically, F double prime is positive. Okay, all right, so this is the analyzing, this is the graph. It should back itself up, but mostly we're going to be looking at this little detail. Okay, now check out the slopes because it says here the slopes increase. All right, so if we think about slopes on here, they start out pretty steep. They flatten out, so now they're zero. It's zero, sorry. Then they become, these are negative, then they come positive. So all along here from here, sorry, my pen didn't work, here all the way to here, our slopes are increasing. Okay, that is very difficult to back up with math, so we're going to stick with this right here, okay, for the most part. I think it's better for everybody. All right, but by the same token, slopes decreasing. You start out, talk about our slopes of our tangent lines. We start out pretty steep, positive. We eventually flatten out, so that's zero, and then we go to negative. So from beginning of concave down to the end of concave down, the slopes all decrease, okay? All right, so we started positive, we went to zero, we went to negative. Okay, so again, we're going to stick with this piece instead of the slopes because I think that is more clear. All right, we talked about this. Remember, F is, so I don't think we need to go there. F double prime is negative, yada, yada, yada. Okay, so I already talked about all that visually, so you can read that later if you like, or take a minute now to read it. Okay. Next, we're going to look at this graph, and please note that this is F prime, not your usual F that you're used to looking at, okay? So this is F prime function. It's, you got to wrap your head around that. Okay, where is F, which we are not looking at, increasing or decreasing? Okay, so my F is increasing when F prime, remember from the other day, is positive. So we're back to increasing and decreasing. All right, so increasing, F is increasing, F prime is positive. Don't say it, okay? It has, we're talking about F, we're talking about F prime, we're talking about F double prime, so stay away from it. Okay, so F prime is positive. Well, looks like, remember, positive when you're looking at the graph is above the x-axis. So here's positive, that's negative now, and here's positive. So on those two intervals, so what are we talking about? Oops, didn't want to do that. Hello, what's going on? Okay, we are going to talk about negative infinity to, that looks like -3. Come on. And then again, what's that other piece? 1, 2, 3, 4. Let's go with 4 to the rest of it. Okay? All right. And by the same token, decreasing would be where F prime is, which is what we're looking at, negative. Okay? F prime is negative on, let me do a different color, this piece right here, below the x-axis. So of course, if we follow this same thing, that must be from -3 to 4. Okay? All right, now concave up, concave down. Alrighty then, concave up is where F double prime is positive. Now, F double prime, remember, are the slopes of F prime. The value of the slopes are either negative if they're falling, they're 0, or they're positive. Okay, so now we have to shift, and I'm going to erase this color because I'm going to talk about concavity now. All right, concavity are slopes. All right, let me get some colored lines. Let's do orange, just so we can step them out. Okay, so right now, looks like I'm talking, what kind of lines are we talking about? Negative slopes until we get to about right here. Okay, so using my orange pen, maybe, I don't really have one, so I'll do green. Let's say those are negative slopes of F prime, which means F double prime is negative. Okay, so that would not be concave up, that would be concave down. F double prime is negative. Okay, so on the orange piece, it looks like it's from -infinity to 0. And if you can't tell, you just make your best guess because it's an estimate. Okay, because that's all we're doing. All right, now, once we get to 0, let's get my lines back again. Oops. Let's talk about blue lines. Okay, once we start that 0, remember these lines now, those are my slope, my tangent lines, they are going to go positive. Okay, so now we're talking about this concave up. So these lines here, blue pen, here's my blue pen. Oh well, a black pen. Okay, F prime, sorry, not F prime. The slopes, just to be consistent, these have positive slopes. And remember, we're talking about the slopes on F prime because that's what we're looking at. So we're talking F double prime is positive. So that is concave up. So that is from 0. We got to start with the same point here to, oh, let's see. Let's say it's right there. We're estimating. So what's that? 1, 2, 3, 4, 5, 6, 7. We'll go for 7. Okay. All right. Well, look what happens. After we turn around, we're going to go back to our negative lines, which are our orange ones. Oops, that one. All right. And we're going to make negative, negative. Okay. So those are, again, negative lines. So we have to do another concave down because they're negative slopes, which is the slope of f prime is f double prime. So that means we started at the 7 and we went to infinity as far as we know. Okay, because that's all we know. All right, now we haven't talked about inflection points. Okay, so let's go back here and look at what an inflection point is. Inflection point is where the direction of concavity changes. It's sort of like the max and the min of the double prime. So let's say you have a function that looks like that. Okay, so kind of in the middle of concave up and concave down. Let's say that's it. And again, this is hard to tell exactly where it is, so I'm just guessing, but we're going to be able to tell it by the function here in a minute. This, of course, is concave. It's pointing down, so it's concave down. It's opening down, rather. Okay. This is concave up. And then again, it looks like it might be starting to turn down again. That's concave down. Okay. All right. So at these points right here, we have an inflection point. We'll call that an IP. Inflection point. Okay, so that's what it is. Let's find them. All right, now, oops, they're ordered pairs. Typically, if we can do. So here we're going to do, it looks like at what values of x, that's usually what we're going to do. So we changed right here. And we changed right here, just to be clear. Now, again, using those same estimated values here, there's an inflection point at x equals 0 because we changed from concavity. Here's concavity. We went from 0 over here to concave down to 0 over here to concave up. So there's a change there. It doesn't matter if it's changing from negative to positive or positive to negative. And then again at 7, we were at concave up and we changed to concave down. So x equals 7 is a inflection point. Now, you don't want to tell me it's 7, you know, like 2, because remember, this is f, and this is not f, it's f prime. So, okay, and we're not going to really worry about doing this right now, because I think we need some more instruction. So anyway, we're not going to do that, and we're not going to do this page ever, okay? So, new page, or extension off the other page. Let's review what we know about f, okay, is increasing when f prime is positive. Okay, f is decreasing when f prime is negative. Okay, f is concave up when f double prime is positive. F is concave down when f double prime is negative. Okay, at the splits, when it changes, whatever you want to call it, we have inflection point. Okay, at these splits, we have local max or min. Okay, can we be clear about that? Okay, a local max occurs when f prime changes from positive to negative. A local max occurs when f prime changes from negative to positive. All right. Let me pause for a minute and get. Okay. We are back and we're going to get your equation popped in here. Actually, we're not going to do that yet. Okay, my equation I'm going to work with, and I'm going to talk about all this increasing and decreasing is, you don't need to put it in your equation a calculator yet, but you can. Y equals 3x to the third plus 8x squared minus 4x minus 1. Okay, so we're going to use calculus to analyze, and then we're going to make sure that backs up with your graph. Your graph is never going to be because it looks like that on the graph. It's never going to be never going to be a reason to justify something. Okay, this is calculus, not pre-calculus. Okay, here we go. So first we're going to do y prime. All right, you want to pause it for a minute while you do y prime? All right, here we go. 9x squared plus 16x minus 4. All right, is that a good one? I didn't think about. Okay, so now we want to know plus or minus for increasing and decreasing. Okay, so that means before we can do plus or minus, we have to do 0. So y prime equals 0, where 10x squared plus 16x minus 4. Now, sometimes this is a nice, pretty, solve it, accurate. Sometimes it isn't. So I'm going to pause it for a minute. Okay, did you get it factored? It does factor. Praise the Lord. It is 9x minus 2 and x plus 2. Okay, if those two factors are equal to 0, x is equal to 2/9 and negative 2. Okay, what that means is your zeros are at negative 2 and 2/9. All right. So on all sides, either this interval, and this interval, we are talking about either positive or negative because these are the only zeros. All right. So we're going to do interval testing like we did in pre-cal. All right. Let's try 0 in this one. Let me do a different color so you know which I'm trying. And let's try 2 in here, and let's try negative 4 in here. Okay, so basically, you are testing f prime. You are trying to see if it is negative or positive and then you know whether it's whether f, excuse me, I used it, is increasing or decreasing. So we're going to try negative 4. And really, you don't have to go crazy. You're just looking for the sign, positive or negative sign. Okay, so f prime is, remember, 9x minus 2 times x plus 2. All right, so when I put it in negative 4, I'm going to take 9 times negative 4. That's going to be definitely negative. Okay. When I put in a negative 4 plus 2, that's going to be negative. 2 negatives multiplied equals a positive. So above this number line, I'm going to get rid of that. and I'm going to put f prime positive. Okay, I'm not just going to put positive because I'm going to do, you're going to see why here in a minute. Okay, I'm putting in 0 now. Here we go. 9 times 0 minus 2 is definitely negative. 0 plus 2 is positive. A negative times a positive is a negative. So again, I'm going to get rid of this dude right here, and I'm going to put in f prime negative. All right, while I'm at it, I'm going to erase this. Okay, I'm plugging in a 2 now. 2 f prime. 2 times 9 minus 2 is definitely plus, and 2 plus 2 is definitely plus. This is going to be plus. F prime is definitely plus in that section. Remember, you're testing one number. If one number tests out, okay. Also, don't forget, this is a quadratic, so it is a parabola, so it's going to do this business. Open up. So remember, this piece right here is going to be above the x-axis. This piece is going to be above the x-axis. This piece is going to be below. Okay, so f is increasing. Let me do a new pen here. How about blue? F is increasing, where f prime is positive. So that is, oops, I don't want to do that. Okay, increasing is all parentheses. All right. Hello, what happened to my pen? Okay, positive would be from negative infinity to negative 2. And then again, from 2/9 to infinity. Okay? And then decreasing would be the other one. F prime is negative on this, negative 2 to 2/9. Okay? So there's increasing and decreasing. Sorry, my pen is sloppy. Okay. So now let's talk about concavity. Okay? Concavity is, let's go back to purple. All right. Concave up. Oh, wait a minute. Let's talk about local max. Where's our local max? We went from, if you look at your graph here, you went from positive to negative, so there's a local max at that split, which is negative 2. And then there we went from negative to positive at 2/9, so that's a local min at x equals 2/9. Okay? All right, I'm going to start a new page. And we're going to go do concavity. Okay, so before I can, let's do dual page for a minute. All right. So I need to look at the function. All right, so or not, come on. All right, I go back to single page. Oh, it's right here. Okay. So let me grab this. Oh gosh, snip. You are enjoying this, aren't you? Ah, some things never change. Okay, here we go. Here we go. I'm snipping my equation. All right. So going over the next page, and we're talking about that equation. All right. We already did y prime. I'm just gonna, seems like it'd just be easier to, it's very large. Oh my gosh. All right, so y prime is, remember, 9x squared plus 16x minus 4. Okay, now we're looking at y double prime. Okay, go ahead and pause. All right, you're back. 18x plus 16. All right, so we want to know concavity. Just to be clear here, we want to know where f double prime is positive. That would be concave up. And f double prime is negative. That would be concave down. Okay, so before we can do positive or negative, we have to do zeros. So 0 equals 18x plus 16. Negative 16 equals 18x. X equals negative 16 over 18. Ew, what the heck happened to that? Oh my goodness. Jeez. Oh, we love. Okay. Back to the pen. 18. Reduce. And we have what? Negative 8/9. Okay. Now, this is a possible inflection point because we haven't checked concavity yet, so we don't know if it changes. Remember, that's where you find it. Inflection point is where it changes. Okay, so we're going to do the same thing. Here's my 0 at negative 8/9. And what we're going to do is check in the intervals the second derivative, the double prime. All right, so here we go. Get my red pen out for my interval testing. We get x, and we're checking f double prime, which remember is 18x plus 16. Okay, let's see. Over here, let's just check negative 2. Over here, let's check 0. All right, negative 2. 18 times negative 2 is negative 36, plus 16 is definitely going to be negative. Remember, that's all we want, so I'm going to put a negative right there. Okay, 0. We don't really care about the number. We just care about the negative or positive number, the sign of it. Okay, 0 plus 16 is going to be positive. Here we go. Okay. All right, so now we have concave up and concave down because concave up is, go back to my blue pen, where it's positive, so that would be at negative 8/9 to the rest. Okay, and concave down would be where f double prime is negative, which would be negative infinity to negative 8/9. All right, go ahead and put it in your calculator. Good grief. Okay, I'm back. We have a graph. We have a terrible window, probably. Let's see. Oh, not too bad. Okay, so let's check out what we know about this thing. I'm going to go back to double window and a blank window. Okay, so my graph, well, looks like that. All right. Now, we should be able to verify everything we just found analytically with the calculus. Okay. So let's blow this up. And you're going to look at, never mind, I can't, negative 8/9. So on your calculator, let's do second trace negative 8/9. Oh, for gosh sakes, value. Negative 8/9. Okay. That looks like it's our concavity switches. Do you see that? Well, right there. Okay. Concave up from here to here, concave down, the rest of it. Okay, which is what we said right there. All right. Let's talk about increasing and decreasing. This is F now, remember. Increasing and decreasing. Let's see. Let's go back and switch these around here real quick. All right. Your local max, remember, was if you had x equals -2. So let's go back and let's look at -2. -2 is definitely a local max. Okay. 2/9 is definitely a local min. And then you can tell that it's increasing and decreasing. So that's the analysis that you're going to be doing in your homework. Good luck.